is overhauling of VCB, Schneider and AAL. So first I will give you what is VCB, what are the makes of VCB available, how it was classified, and how overhauling of VCB is carried out, and how many makes VCB available with us. Okay, so let's start. What is circuit breaker? Circuit breaker is used for making and breaking of continuity in a circuit. Okay. So what is circuit breaker? Circuit breaker is used for making continuity, and it is also used for breaking continuity in case of some faults occurs in the circuit. Okay. Such as a short circuit, overload voltage, etc. In that condition, the circuit breaker will automatically disconnect the circuit. Then according to the voltage used, low voltage circuit breaker, medium voltage circuit breakers, and high voltage circuit breakers are available. We said that in circuit breaker, whenever making contacts and breaking contacts, there will be arc formed. This arc to be conjured of in this arc to be conjured of. This can be done in several ways. We can use vacuum, or oil circuit breakers are available, SF6 circuit breakers are available. So depends upon the conjing of, depends on the type of conjing used for conjing of this arc. We can frame circuit breakers as vacuum circuit breakers, oil circuit breakers, SF6 circuit breakers, etc. In our locomotive, we use vacuum circuit breakers. Vacuum circuit breakers, the conjuging of arc is done using vacuum. Okay. So why vacuum is used? Whenever making that contact, arc will be formed. This arc will ignite only if air is available in that area. So if vacuum is present in that area, that conjuging will happen immediately, and there won't be any other problem will happen in the circuit. So in our locomotive, we use vacuum circuit breakers, and vacuum circuit breakers are used for medium and high voltage applications. Okay, and our vacuum circuit breakers rating is used in 25 kV, 50 to 60 hertz. Okay. And in our loco, we use, there are three types of VCBs actually present. We use only two types. One is Schneider maker and another one is AAL maker. Besides that, one BTAL is also available, but we are not having any BTAL maker VCB in our loco. This is the basic diagram how VCB is operating. Okay. While we are switching on ZCPA, this Panto reservoir pressure or already available MR pressure will be available. It will be around, if PR is available means it will be 8 kg. If MR is available means it may be up to 10 kg it will be available. It will be given to PRV. Rupture capacity data I will give you. That I have written, but I don't remember that. 10 kg incoming was given. Okay. In main reservoir, it will be around MR. MR will be 10 R. 10 kg will be available. It will be given to PRV. PRV means pressure reducing valve. Okay. What will do this PRV is, this 10 kg or 8 kg PR will be reduced to 6 kg in case of Schneider VCB, or 4.8 kg pressure in case of AAL VCB. Okay. So up to this, the pressure will be around 10 kg in case of which is MR, or 8 kg this, if it is PR. Then after PRV, the pressure will be 4.8 in case of AAL and 6 kg in case of Schneider VCB, and this air will be stored in a small reservoir. It is very small. It is inside that VCB, and this pressure will be given to one pressure switch also and one EP valve in case of AAL VCB, or relay valve in case of Schneider VCB. Okay, this pressure, if the pressure is above 3.6 kg, okay, here 3.6 kg, then in case of AAL VCB, this pressure switch will close. Okay, 110 volt will be available here. Incoming 110 will be available up to pressure switch here. If the pressure it will be checked, 110 supply will be available here. It will check whether pressure is available above 3.6. Then only this pressure switch will close and it will give supply to EP coil. Okay, and here pressure is also available. Whenever supply is available here, this EP coil will energize. Whenever the EP coil is energized, this EP coil air will come to EP valve and EP valve also will start to function. And from this EP valve, air will be given to operating rod. This operating rod will be activated. That the operating rod will be moved. Okay. Operating rod will be moved with this pneumatic pressure, and this operating rod will in turn move this this mobile contact. Okay. This mobile contact will come in join with the fixed contact. So this circuit will be closed. You understand? Here 25. Here it is 25 kV available. Whenever this is getting contact, mobile contact will get from this outgoing will be taken. Okay, you see, up to this one only pneumatic pressure is available. Okay, these are all LT part, low tension part only. Okay, 110 volt supply only available. This is intermediate part. This is high tension part. Here 25 kV available. This is intermediate part, and this is the LT part because there is only 110 volt available in this area. Okay, this is used for controlling. How to? This is used for the mobile contact to work to mobilize this mobile contact. This is the operating mechanism. Okay. Then we will go for Schneider VCB. Rated voltage is 25 kV, continuous current 1000, frequency 50. This total travel is given. Contact gap. Contact gap means this gap between mobile and fixed contact. That is 7.4 to 8 mm. Contact hour travel 4 to 4.9. That is for where this mobile contact and fixed contact. Mobile contact will cross. Okay, but there should be some pressure. We have to ensure that this is correctly and with the correct force it is getting contact. There should not be any less force also, more force also. If it is less force means there will be not proper contact. If there is over pressure means that contacting area will get damaged. Okay, so for that one only contact our travel is there. Contact here 3 mm. Okay, and operating time is very much less than closing time. Why? Because if there is any fault in the circuit, that circuit breaker should immediately trip. That is why always opening time should be will be always less than closing time. This is the magnetic valve used in that Schneider VCB. This is a Rotex valve, Rotex coil. Its operating voltage is 110 volt, minimum operating voltage 70 voltage, and maximum operating voltage is 125. And you will check its resistance. Resistance is 1600 to plus or minus 5%. This is the pressure switch. Actually, this is AAL VCB I have shown here. Both are using same only. Indiforce only making used in both AAL and Schneider VCB. The cutting cutoff range is only different for this one. Schneider VCB 3.8 to 4.75. 3.8 is the cutoff. Cutting is 4.75. That is. Sir, that is whenever the pressure is more than 4.75, then only this QPDJ will be closed. Through that only this 110 volt supply will go to EP coil, and EP coil will energize. If the pressure is below 4.75, what will happen is this QPTJ, if the pressure is gone below 3.85, what will happen? QPTJ will be off. So it will not allow the voltage to go to EP coil. For what purpose it was given like this means, if the pressure is less, the closing should not be happen. If pressure is low means this chattering will happen. It will not make a proper contact. There will be poor contact. There will be arcing will happen. This many problem will happen there. So this it will ensure that the pressure is whenever it is closing, the pressure initial should be 4.75. It will ensure. Okay. If the pressure reduces below 3.85, it will automatically off and the supply will not go to EP coil. This is the pressure regulator, PRV. This is used to reduce and regulate the pressure. Okay. In Schneider VCB, we use earlier we are having Shavo and Parker PRVs. Now we are gone for CKD PRV. And the pressure setting is 6 kg. Okay. In AOH, what are the tests we have to do in the VCB? It is given for Schneider and AAL. First we can say electrical HT test, coil value, scope. This will come under electrical, and operation QPDJ PRV leak test, that we can say it is mechanical parameters. First, let us take Schneider VCB. In Schneider VCB HT test, how we are carrying out is 60 kV will be applied across it in off condition. First, it will apply to incoming. Okay, that is 25 kV incoming and 25 kV outgoing. We will check it. Okay, 60 kV for 1 minute. Okay. Then second is from outgoing and earth. That also we will check. This is the HT test we are conducting. In AAL, the parameter, the voltage is 40 kV for 10 seconds. Okay, that is the different. 40 kV for 10 seconds. It is also in the same way only. Incoming, outgoing first, then outgoing earth. Then coil values that I have already shown its values. Then last, after in AOH and IOH, the kit will be provided by as per SMI. That we have to change. That is the overall procedure. After that, we will take scope. What are the parameters that I will show? In that, contact gap, over travel, this speed, opening speed, closing speed, that we will measure. Okay. Then operation we will do. What is operation? 200 times operation of coil and VCB closing opening, that will be checked during in that test. This QPDJ we have to set it properly. In case of Schneider, it is 3.8 to 4.7. In case of AAL VCB, it is 3.3 bar 3.6. Then PRV. PRV is pressure reducing valve, that we have to keep. In case of Schneider, it is 6 kg, and in case of AAL, it is 4.8 kg. Okay. Then leak test. Leak test also we have to carry it out. In Schneider VCB, we will carry it out in off condition and on condition. That we will check it. Okay. That I have already told you. High voltage test 60 kV will be given for 1 minute, and we will, with the break and open condition, we will check between incoming and earth, between outgoing and earth. That is the procedure. This is operation test. Then air leakage test. Air leakage test in VCB in off condition. Okay, we will apply pressure of 6 kg. 6.5 kg. Sorry, 6.5 kg we will apply, and we will wait for 10 minutes. If the pressure drop is more than 10% of set value, there we have to arrest the air leak. In closed condition, in open condition, the air will be available up to relay valve. Okay, it will not go beyond the relay valve. It will be available up to relay valve. So, if there is a pressure reduce of more than 0.65 kg, we have to check from where the leak is available and we have to arrest it. Okay, and the same procedure we will do for after in on condition also. In on condition also we will check with the 6.5 pressure kg we will apply and we will check is there any air leak of more than 10 percentage of set value. 6.5 we will set 0.65 is the set value. So the pressure should not be dropped more than 5.85. The pressure should be at least 5.85. Then only we can ensure that there is no air leak and the air leak is within standard limit and there won't be any problem while operating the VCB. Okay, if the pressure is reduction is very more means the VCB will not. Sometimes the pressure may be very drastically reduced and VCB opening chances are very high. This is the pressure switch fitting that I have already told you. This is the torque of Schneider VCB we have to use. This is base plate 30 Nm, main terminals 40 Newton, earth terminals 30 Newton, and upper and bottom insulator that we have to apply 16 Newton meter. Then we will go for AAL make VCB. This is the given minimum limit voltage, rated operational voltage like that. This is the input terminal, output terminal, intermediate part and lower part. This is controlling part. Okay. This is the main HT part. This is the intermediate part. Here only this movable contact available. Here fixed contact is available. 25 kV cable will be given to here and outgoing will be taken from this area. Okay. This is the EP valve and coil used in AAL VCB. Its resistance is 1510 plus or minus 8% and operating voltage is 110 volt. This is the pressure regulator used in AAL VCB. Earlier we have used Bachofen PRV. Now we are replacing this Bachofen PRV with CKD PRV. Testing already I told you in HT we are giving 40 kV for 10 minutes. Sorry, 10 seconds. This is the procedure I have done. Leak test. In this one we will apply only in HT part only we will give. Here we will give this part only. Is there any leakage for checking any leakage? We will given to this area. Okay. 0.8 kg pressure will be applied for 30 minutes and 30 minutes. If the pressure drop is less than 0.05 kV, it should be less than 0.05 kg pressure. Okay. This is the scope parameters. Total travel, over travel, closing speed, closing timer, bounce timer, contact gap. That will be given through this scope parameters. One separate instrument is there that we will use to check this scope parameters. The specification is CLW specification for this one, VCB Schneider and SMI 236 annexure. Based on this annexure only, we are replacing this AOH and IOH items. This one SMI RDS 281. This one is for Schneider VCB to prevent moisture entry between bottom insulator and top insulator. There is one groove is available and one O-ring we will provide. In that area, we have to use Loctite 518 that to prevent moisture entry into the VCB. That is this SMA. This SMA 285 that is also for Schneider VCB. It is telling that we have to apply RT1080 in the bottom evenly and 5 mm width with a proper thickness. That is SMA 285 and that is for preventing moisture entry into the VCB. This is the different torques to be used in the VCB. And the most common failures we are facing is one is compression spring failure. Till now we have detected 4 cases. In this one, there is one spring is available. This is compression spring. Its actual purpose is to open the VCB during opening time. It is this spring that ensures the opening of VCB. So there are 4 cases we have detected. Out of this, one is lane failure. So our action plan is to replace this spring in every AOH. Recently, this initially this PRV pressure was 4.2. Now they have increased due to some, and it was reached up to 4.8. So they have not changed any specification of this spring and all. So it is used to crack now nowadays. We decided to change it in every average, so this crack will be reduced. Second one is bottom seal seat failure. This is also in AAL VCB. Number of VCB checked 28. Number of cases found is 7. Actually, this one the problem is in 2019-20. In that lot only this problem is happening. So we have checked all this and found in number of cases 7 found. We have replaced and all, and a company given replacement all. And PRV setting variation. In Schneider VCB, we have used first Shavo PRV available, then Parker PRV available. In this PRVs, what the problem is, this PRV setting will vary automatically. If we keep it 6 kg also, it will vary. After some time, it will go to 5.8, 5.6 like that. Besides that, if we close this VCB, there will be some PRV drop will be available initially. It will vary, depends upon the PRV itself. In some PRV it will be around 0.6, some PRV it will be around 1 like that. If PRV pressure also reduced and while closing this pressure reduction also increased, what will happen is QPDJ pressure switch pressure will be the pressure may be less than QPDJ setting. Okay, so VCB will open and chattering will happen. That is the issue with the Shavo PRV. Same problem is available with the Parker PRV also. In Parker PRV, what will happen is if we set at 6 kg, after sometimes it will show 5.4. After some time, it will again come to 6 kg. That problem was happened in Parker PRV. So we have replaced all this with the CKD PRV. This CKD PRV, it has better characteristic performance because of its components are very rigid and components are very rigid and it is showing a constant cara against this volume and velocity of air coming to PRV. So CKD given much better cara. So we are going for CKD PRV in both AAL and Schneider PRV, Schneider VCBs. In AAL we have used Bachhofen PRV, but Bachhofen PRV also having same issue. This PRV setting will vary in some 1 or 2 cases, and it will go below some 4.2, 4.2 like that. And if drop is also more, this may eventually lead to VCB failure. Okay.